Hey everyone, and welcome to this explainer. Let's just jump right in. So, the other day, I was running a side-by-side comparison test between Claude and ChatGPT, and while I was digging through Anthropic's platform documentation, I stumbled across a phrase that kind of made me pause: knowledge cutoff. Now, I know what that means on the surface, but it got me thinking about the actual nuts and bolts of how these systems operate behind the scenes. So I started digging. And honestly, what I found completely shifted my entire perspective on how the generative AI industry is actually built. Encountering that simple phrase, knowledge cutoff, really made me fundamentally question my basic assumptions. Because, if you follow financial markets or tech news, you probably think the main story is literally just about semiconductors. It's all about how many GPUs can NVIDIA supply this quarter, or how rapidly is Google expanding its custom TPU infrastructure. But looking at that knowledge cutoff made me stop and ask, wait, is generative AI really just a massive tower built entirely on GPUs and TPUs alone? Is that the whole story? To get to the bottom of this, let's look at the specific distinction Anthropic makes. For their latest models, like Claude Opus 4.8 and Claude Sonnet 5, they list a reliable knowledge cutoff of January 2026. But they also list a training data cutoff of January 2026. So what's the difference? Well, the reliable knowledge cutoff is the date through which the model's grasp of the world is considered the most extensive and dependable. The training data cutoff, on the other hand, is the broader endpoint of all the data fed into it during training. Sometimes these dates are exactly the same, but for other models, they can actually be different. They're closely related for sure, but they are not always the exact same thing.
Figuring that out made me realize just how flawed my old mental model really was. Up until then, I had pictured the structure of generative AI like a simple vertical chain. In my head, it looked exactly like a top-down factory line. First, you have the massive computing engines at the top, NVIDIA GPUs and Google TPUs. I kind of assumed those systems somehow just directly produced OpenAI's training data. Then, that data creates GPT, and finally, we access GPT through an app called ChatGPT. Just a neat, straight line from the hardware right to the user.
But thinking about the reality of how a model's knowledge is actually capped and tested, I had this sudden pivot in my thinking. Wait a minute. Training data doesn't actually come from GPUs or TPUs. I mean, a piece of silicon doesn't just magically dream up historical facts or Python code on its own, right?
So the reality is, we are looking at two completely different infrastructures. On one side, you have the computing infrastructure, the GPUs and TPUs, like Google's Trillium or their 7th-generation Ironwood. That is pure computing muscle. It's the engine. But the training data comes from a totally different direction. This is the information infrastructure. We're talking text, images, programming code, licensed material, public web data, even synthetic data. That's the fuel. The exact recipe changes between companies and models, but the key takeaway is that computing power and training data absolutely do not sit in a single vertical line.
When we rethink this, we build a much more accurate puzzle structure. Instead of a vertical chain, it works like this. All that educational material, the text, images, and code, is collected and organized by the AI companies. Then, they combine it with the raw brute force computing power from those GPUs and TPUs. When you smash that information and compute together, the output is the generative AI model. And then, as the final puzzle piece, that completed model gets hooked up to a specific service interface so human users can actually interact with it.
And thinking about it as a puzzle brilliantly clears up another vital distinction that is so incredibly easy to miss. GPT and ChatGPT are not the same thing. GPT refers to the family of generative AI models created through that massive training process. It is the underlying brain. ChatGPT, on the other hand, is just the window that lets human beings communicate with that brain. The exact same rule applies to Anthropic. The Claude model is the brain, while Claude.ai is the window you look through. They are inherently connected, but they perform entirely different roles.
Which brings us right back to our initial mystery. So why do these developers actually need to define a cutoff date for a model? Well, AI companies could theoretically just constantly collect new information. But if the training material kept changing indefinitely, it would literally be impossible to finish the model. Developers have to eventually define and stabilize the data. They need a frozen snapshot so they can run that large-scale training, evaluate its capabilities, heavily test its safety and reliability, fix its weaknesses, and finally release a stable product to the public.
Now, you might be thinking, but my AI can search the web for today's news. And that is absolutely true. Events that happen after those cutoffs are handled through web search, connected tools, or documents you upload directly into the chat. The completed model can read that brand new information and reason about it in real time. But here's the catch.
Reading that new information during a chat does not automatically permanently rewrite that information into the model's underlying knowledge base. The already trained model is basically just processing your prompt and the search results in its active, temporary memory.
If developers actually want to bake new knowledge deeply into the model's core parameters, they have to run additional training. Because building generative AI involves two massive, very distinct stages. First is pre-training. That's where the model learns broad relationships and patterns from enormous collections of text and code. Then comes post-training. This is where developers use human-created examples, evaluations, and rules to adjust exactly how the model responds, shaping it to follow instructions, handle complex situations properly, and just behave well with humans.
And that brings us to what I think is the most overlooked, almost hidden aspect of this entire industry: the invisible information foundation. Everyone talks about the computing infrastructure, the hardware, the giant data centers, the electricity grids. But all that physical hardware is entirely useless without carefully prepared educational material. It's this information foundation that dictates what text, images, and code are used, how copyrights and usage rights are legally handled, and which cultures and languages get represented. These processes are largely invisible from the outside looking in, but they fundamentally dictate how a model understands our world.
And here's something crucial. Simply having more training data does not automatically produce a better AI model. If you feed it duplicated, outdated, or wildly inaccurate information, the model just learns those flaws. What makes training data genuinely valuable is accuracy, recency, diversity, legal access, and the ability to strictly filter out spam and duplication. Human evaluation during that post-training phase is incredibly vital. Therefore, knowing how to select and prepare this information is a massive, often underappreciated competitive advantage for these AI companies.
So that begs the question, are we only looking at the hardware race? When we look at the financial markets, we get so heavily focused on the physical infrastructure. We consistently ask, how many GPUs can NVIDIA supply? How far can Google expand its custom TPU infrastructure? We obsess over the massive capital expenditure on data centers and electricity. And yes, these are absolutely vital questions. But computing power alone cannot create a high-quality AI system without that carefully curated educational material.
The generative AI race is actually a competition across 4 distinct layers, not just a single battle over GPU performance. First, companies must secure powerful computing resources. Second, they must access and legally secure high-quality information. Third, they must have the elite talent and architecture to actually build, evaluate, and adjust strong generative models. And fourth, they need distribution, getting that completed technology into people's daily lives and enterprise workflows.
When we map out the ecosystem this way, we see how these incredible companies support entirely different layers of this wider industry. NVIDIA is supporting the foundational hardware and software infrastructure to train and run these models at an enormous scale. Google operates across the board, from custom TPUs and cloud networks all the way to their own models and massive consumer distribution. Microsoft provides the Azure cloud infrastructure and incredible distribution channels through its global enterprise software. Meanwhile, you have OpenAI and Anthropic focusing heavily on developing the frontier models themselves, perfecting post-training, evaluations, and the services that connect those models to users. They sometimes compete, but they also cooperate.
So the really crucial point I want to leave you with today in this explainer is that the other foundation, the information foundation, matters just as much as the computing power. GPU performance can be measured. You can literally count the chips and estimate data center electricity demand, but it is far more difficult to see exactly what a model is being taught, where that information came from, and how its behavior was meticulously adjusted. Yet it's that carefully prepared information meeting the massive computing power that creates the actual intelligence.
News alone will not show us the full market. What matters is identifying what is happening now and understanding what the market itself is watching.
From that perspective, let's continue thinking about it together. Thank you for watching.